Okay, so in the previous class, we have done with the hydrogen fuel cell. And today we are going to start with the electrolysis of dilute sulfuric acid, where we are going actually using the graphite electrode. If you recall, the graphite electrode are the inert electrodes, which means they do not react. Okay, so the electrolyte that we are using over here is dilute sulfuric acid. And when we talk about the dilute sulfuric acid, so sulfuric acid have, you see, hydrogen and a sulfate. So there is a hydrogen ion and a sulfate ion in the solution. And as it is aqueous, so which means that it is dissolved in water. So being aqueous, it have a hydroxide ion and hydrogen ion as well. So the hydrogen ion is the common ion which is present in the electrolyte as well as in the water as well. So that's why here we are getting three ions. Beside this, for example, if I give you the example of sodium chloride aqueous. So here what we are going to have, we are going to have a sodium ion, chloride ion, hydrogen ion and hydroxide ion, because being aqueous, dissolved in water, water is producing these two ions and this electrolyte is producing these two ions. In the similar manner, for example, if I talk about the copper sulfate, copper 2 sulfate aqueous. So as copper sulfate is an electrolyte, so we are going to have a copper ions and sulfate ions. And as it is aqueous, there is a water, so that water is producing hydrogen ions and the hydroxide ions. So see, the hydrogen ion is always coming from water, but as you see, there is a water, aqueous it is, but beside this, the compound, the electrolyte also contains hydrogen ions. So that's why we are having three ions, not four, as you are observing in the above two cases. Is this point is clear? Yes, Aisha?
Yes, sir.
Okay. Now, if you see, there is no competition between the positive ions because we got only one positive ion. So at the negative electrode, if you see this negative electrode, this is the negative electrode. At this negative electrode, only the hydrogen ion is going to be attracted and get reduced, and as a result, it forms hydrogen gas. And we show this reaction by this equation that there is a positive ion. So it means it needs a one negatively charged particle to neutralize it. But when it gains electron, it becomes hydrogen. That hydrogen is always diatomic, which means we need two hydrogen ions, and for two hydrogen ions, we need two electrons. So that's what happens at cathode. Now, let's talk about anode. At anode is a positive plate or positive electrode. So there are two ions over here which are negatively charged. So as the rule states, which we have discussed earlier, that whenever there is a sulfate ion, that sulfate ion is never going to oxidize at anode. Only hydroxide ion is going to oxidize at anode. So see, that's hydroxide ion oxidizes at anode, forming oxygen, water, and releasing 4 moles of electron. Okay, but if you see at the top of the two tubes, one is above cathode and the other one is above anode, the gas forming over here, there is the volume of both the gases are different. If you compare, you can figure it out that hydrogen is exactly or almost double than oxygen, right? So the reason behind this is that, Assalamualaikum. See the time?
Sir,
So if you see, when 1 mole of hydrogen gas is formed, it is formed by the release of how many electrons? By gain of 2 electrons. When 1 mole of oxygen is formed, how many electrons are released? 4 electrons. So think, when 1 mole of oxygen forms, it releases how many electrons? If these 4 electrons are provided over here, then how many moles of hydrogen is going to form? 2. So see, the amount of hydrogen that is forming at cathode is exactly double than the amount of oxygen forming at the anode for the same number of electrons. So as the amount gets double, the number of moles of hydrogen gets double. That's why we are getting the double volume of hydrogen when the oxygen is half of it. Is this clear? Yes, Aisha, did you understand this? Okay. So here, this whole chapter is completed. You were there in the class before the last one. So just complete these down. I'm going to share the notes on the WhatsApp group. You all have been added in the WhatsApp group? You are not? Okay. So tell Sarasan to add you there, then I am going to share all the notes. Just copy this down, then we will going to see some past papers from electrochemistry. So just I'm going to give you a quick summary, then we will discuss the past papers. Okay. Do this quickly. This was the last topic. Copy it as well. Let me. So if you see the hydrogen that is collected over here is double than the oxygen, right? So if you see when 1 mole of oxygen is formed, how many electrons are released? And when 1 mole of hydrogen is formed, how many electrons are gained? 2. So if these 4 moles of electron are released, and if they are being used over here, then for 4 electrons, we need 4 hydrogen ions, and then how many moles of hydrogen is formed? 2 moles. So see, 1 mole of oxygen is forming by releasing 4 moles of electron, and those 4 moles of electrons are gained by hydrogen ions to form how many moles of hydrogen? 2. So the amount of hydrogen that is forming is double than the oxygen. So that's what I have explained over here. Is this clear to all of you? Okay. Now, just a quick summary that there are 3 cases that we have discussed. Molten electrolyte, in molten electrolyte, we always use graphite electrodes, and there are only 2 ions. One is cation, and the other one is anion. Cation reduced at cathode to form element, and reduce means
gain of electrons.
Very good, gain of electrons. Anion oxidized at anode to form element, and oxidize mean loss of electron. Okay, so this was the first case. Then the second case was aqueous electrolytes. Here again, in aqueous electrolyte, graphite electrodes are used. Now we got 4 ions, 2 cations, positive ion, and 2 anions, negative ions, right? So out of these 2, one is a hydrogen H positive and the other one is a metal ion. Okay, and here two anions, one is the hydroxide ion and the other one is a non-metal ion, which can be a halide. X negative means that it can be Cl negative, F negative, Br negative, I negative, or NO3 negative or SO4 2 negative. Okay. In this case over here, out of these two cations, one lower in reactivity series reduced at cathode. So you have to memorize the reactivity series. Okay. And here, if diluted, then hydroxide ion oxidized, no matter what are the anions.
reactivity series में जो element नीचे होगा वो ज़्यादा reactive होगा.
That element is less reactive. That's why see the elements are forming. Na? Elements are not reacting. Their ions are there and they are turning back into elements. So he's going to turn back into the element, the one which is less reactive.
Early to get ions will look as positive or and for this was like
We were discussing this since last classes. For example, it's copper sulfate. So there is a copper ion and a hydrogen ion. For example, if it's aqueous sodium chloride, so there is a sodium ion and chloride ion. Oh, sorry, and hydrogen ion. If you are taking aqueous, so every time there is a hydrogen ion and the other ion can be depend upon the electrolyte. So, and that is always a metal ion. So that's why I have written Mn positive, a general symbol. Okay. So if diluted, then hydroxide oxidizes. If concentrated, then halide oxidized to form elements. And remember, sulfate and nitrate never oxidizes. Okay. Is this clear to all of you? Then what is the difference when we use the active electrode?
active electrodes take part in the chemical reaction.
Which one?
Any other than platinum and
No. How? Which active electrode take part in the reaction? Platinum is already anode. So when there is an active electrode, if there is a graphite or a platinum, then it's obvious that those electrodes are inert. If beside these two, if there is any other electrode is provided to you, so it means that is the active electrode. And when there is an active electrode in the cell, then anions from the solution don't oxidizes at anode. That's what occurring over in these two cases, which we discussed. Instead, what happens? That anode itself oxidizes and start dissolving and turns into ions. Okay, is this clear to all of you? Yes, Aisha, is this clear to you as well? Yes, Aisha.
Yes, sir.
Okay. So okay, so have a look at this question. This question have all 3 marks. You guys did hydrogen fuel cell in the last class,
Yes.
right? So hydrogen reacts with oxygen as shown in the equation. A sample containing 1 mole of hydrogen is completely combusted. The sample releases 286 kilojoule of heat energy. The reaction shown also represents the overall process just occur within the hydrogen oxygen fuel cell. So this is the overall process. Describe one advantage of using hydrogen oxygen fuel cells to power a motor vehicle rather than a burning gasoline.
It will be cheap.
It will be cheap. What else?
Sir, pollution.
Good. No pollutants are produced in hydrogen fuel cell. Water is produced. And the another benefit? For here, that's fine. I'm just asking because see it's for 1 mark, so one answer is correct.
Battery is not used in this side.
No pollutant is found. The other one is that it is going to produce more energy. It is more efficient than the gasoline, than the petrol, than the diesel. It always produces more energy. So that is another advantage. Complete the equations for the 2 electrode reaction that happen in a hydrogen oxygen fuel cell. So if you see from the previous class here, we did see the 2 reactions at anode. See the hydrogen gas is turning into hydrogen ions, and so you have to just complete it. You have to put 2 hydrogen ions over here. And if you look at the other one, oxygen plus 4 electrons and 2 moles of water are producing 4 hydroxide ions. So you are going to write 4 hydroxide ions. Is this clear? Yes, Aisha? Okay, now have a look over here. See this question. Aqueous. Now see they have given you the aqueous. Copper to sulfate is electrolyzed using graphite electrode. So graphite is telling me it is
non-active.
inert, non-active. Describe what is observed during the electrolysis. Now see, they didn't ask you the equation. They are asking you the observations. At positive electrode. So positive electrode, which ion is going to be expected? Okay, let's do a little background work. 1 minute. It's copper to sulfate and it's aqueous. So as it's copper to sulfate, it have a copper to positive ion, sulfate to negative ion, hydrogen ion, and hydroxide ion. So at positive electrode, which ion is going to oxidize?
OH negative.
OH negative. See, because we have just, when we just do a summary, we discussed that sulfate and nitrates never oxidizing. So in that case, OH would oxidize. So when OH negative ion would oxidize, what will be the product?
Oxygen.
Oxygen. So when oxygen is found in the solution, what will you see?
Bubbles.
Bubbles. And what color of that bubbles? Colorless. So the observation over here is colorless bubbles. We know oxygen have no color, and whenever the gas form in the solution, it is always, see, there is always bubbles. If you see this diagram, see, you are observing the bubbles, right? Yes, Aisha, is this clear? Now, at negative electrode, which ion will reduce hydrogen or copper? No one of you have remembered the reactivity series. We have just discussed that the one which is lower in the reactivity series. So if you look over here, you can find hydrogen and copper below it. So it means copper is going to oxidize at cathode. That's what the rule for cathode is. If there are 2 ions, the ion which is lower in the reactivity series will always reduce at cathode.
सर जितना रिएक्टिव सीरीज में नीचे होगा वो कितना लेस रिएक्टिव होगा.
Yes.
तो वो जल्दी एलिमेंट में कन्वर्ट होगा.
Yeah. So a copper is found. What is the color of copper?
Silver. Pink solid.
Pink solid. See, you all have seen the copper wires, right? What is the actual color of copper? If you see, its actual color is like this, which we call it copper. But in Cambridge, the examiner required pink for this. So you have to always write pink solid. Now tell me the third observation they have asked, in the electrolyte, what will happen?
And the electrolyte.
In the electrolyte. We both were present in the last class.
Yes.
Aisha, you were there also. See, we did this. Inert electrode, graphite, copper sulfate, the blue color of the solution fades because the concentration of copper ions are decreasing. So in electrolyte, in the solution, we are going to observe this because the copper ions from the aqueous, from the solution are depositing as a solid. So if they are depositing as the solid in the solution, their amount is decreasing. So as their amount is decreasing, the blue color is going to fade. So
CO2 plus in aqueous is blue.
yeah. You were studying here when we were doing redox, right?
Yes.
So just open the notes. I have mentioned all the colors in the redox: Fe2 positive ion aqueous and Fe3 positive ion aqueous and the copper 2 positive ion aqueous. If you see at the end of the redox, so blue color fades. Okay. Now graphite conducts electricity. Give one other reason why graphite electrodes are used in electrolysis.
Because they are inert electrodes.
Because they are inert electrode. Why we are using them? Being inert. Otherwise, we are going to use active electrode. So the other reason is that inert, or instead of inert, you can write do not
Take part.
reaction or do not react. Is this clear? Yes, Aisha, is this clear to you as well?
Yes, sir.
Okay. Okay, now if you see this, a fuel cell generates electricity when hydrogen and oxygen reacts on a platinum electrodes. A reaction at one of the electrode in the fuel cell is shown. State whether this is an oxidation or reduction reaction. Explain your answer. Can you tell me whether it's a reduction or oxidation? We have just noted down the points of the summary. So to see what that states, which thing is oxidation, what happens in oxidation. See, oxidation means, see over here, and reduction mean, right? So if you remember this, and then when you look at this equation here, where are the electrons before the arrow? So it means these electrons are being added up, they are being gained. So it is reduction. Why? Because gain of electrons take place. And if instead these electrons are on the right side of the arrow, so it means these electrons are lost from the substance which is on the left side of the equation. So I'm going to write this is reduction as electrons are gained. Is this clear?
Yes.
Yes, Aisha? Yeah, let's see one mark. And they have explained, if instead they have didn't use this term and they say state whether this is an oxidation or reduction, so you have to just write this is reduction or this is oxidation. That's it. But they have asked you to explain your answer, so we have to add the statement, in the statement, that electrons are being added or electrons are being lost, depending upon what you have identified, whether oxidation or reduction. Okay, is this clear to all of you?
Yes.
Okay. So see, two advantages of hydrogen fuel cell, so you have to remember those. Okay. Now see, Magnesium is produced by the electrolysis of molten magnesium chloride. See, now what we are using? Molten. So it means we are going to have only one positive ion and one negative ion because it's molten, it's not aqueous. Construct equations for the reaction taking place at the negative electrode and the positive electrode. Which ion reacts at negative electrode?
Chlorine.
Chlorine. Mg2 positive. Yeah, it's the simple. Why chlorine? It's negative electrode. So why the negative ion goes to the negative electrode?
Sir, I thought negative electrode was cathode.
No, see, the simple rule is if the electrode is negative, then it is going to attract which ion?
Positive.
That's the simple thing.
Mg2 plus.
Yeah. So Mg2 positive. So how many negative charges it needs?
Two.
Two. So I'm going to write 2 electrons and then Mg. Solid. It is molten, and I have told you in molten the metal formed also is a molten because of a very high temperature. Now chloride goes to the positive electrode. When chloride turns into chlorine, chlorine is always diatomic. Okay, so it means we have to put 2 before chloride ion, so that makes a 1 molecule of a chlorine, because 1 molecule of a chlorine contains 2 chlorine atom. If I write like this, it is not going to be considered as correct. Then how the second atom come, from where the second atom came? So I have to put 2 over here. Now how many negative charges 1 chloride ion have? 1. So if there are 2 chloride ions, then they have a 2 negative charges which are extra. So it means they are going to lose 2 electrons.
Well, we can write -2 electron.
Yeah, on the left side as well. Instead this, you can write this equation like this as well. 2Cl negative minus 2E minus, forming Cl2.
Cl2 is the gas.
Yeah. Obviously at a high temperature, at that high temperature where the metal is molten, so obviously non-metal is formed as a gas only, because non-metals have a low melting and boiling points, but chlorine also exists as a gas at room temperature as well. Is this clear?
Yeah.
Yes, Aisha? Okay. Now see, state the product formed at anode and cathode when concentrated aqueous sodium chloride is used. So see, it's aqueous, right? So it means sodium ion, hydrogen ion, chloride ion, and hydroxide ion. So at anode, which ion is going to oxidize, chloride or hydroxide? It's concentrated. See, if concentrated, then read this point. Then X negative is oxidized, which I have told you, the halogen. If diluted, then hydroxide is oxidized.
It's not concentrated.
Then it's diluted. See the above point. This for here it's not, because there are 2 ions only on the right side where we are talking about the aqueous electrolysis. So chloride ion is going to react at anode, but see, they didn't ask you the equation. They didn't ask you for the observation, they just asked you for the product. So what I'm going to write the product?
Chlorine gas.
Chlorine gas, Cl2. See, in the previous question we made chlorine as the product, right? Now, at cathode, which ion is going to reduce sodium ion or hydrogen ion? The one which is lower in reactivity series, right? And if you see again the reactivity series, because you guys didn't remember it. So see, which is below, sodium or hydrogen? Sodium is at the second position and hydrogen is the middle. So it means hydrogen is going to reduce at cathode, and when hydrogen ion reduces at cathode, it is going to form hydrogen gas H2. So that's how you are going to do it. But for that, you have to remember the rules, and that can only be remembered if you do the practice. That will brainstorm the points in your mind. Otherwise, if you just try that, you will memorize all the thing first and then you will do the past paper. It will be quite difficult. So initially, I always suggest do the past paper with the help of a notes, apply the rules from there, and as you do, the things are keep retaining in your mind and it will help you. Okay, so to the next class we are going to start the next chapter, that is the extraction of metals. And
need to be separated.
I think 11, 12. Let me tell you. States of matter, atomic structure, chemical bonding, metals,
Electrolysis.
redox, electrolysis. Yeah, 6 chapters. Okay.
So total 96 chapters. Total 96 chapters.
No, not that way. In that way, if you count those 26 chapters, so we are done with around 9 or 10 chapters. Okay. See, it's a concentrated solution. You were there in the class when we did this thing. See, reaction at anode, we discuss all the cases. So see, if the concentrated, look at the extreme right, if the solution is concentrated, that it contains chloride, bromide, and iodide, then these are going to oxidize at anode. If the solution is diluted, then no matter what ion is there, always hydroxide ion is going to oxidize at anode. So here the solution is concentrated. So it means not hydroxide, but chloride is going to oxidize at anode. And among these, this hydrogen is below than sodium. So hydrogen is going to reduce at cathode, not sodium. Is this clear? Okay. Okay, then take care, everyone.
Sir, it's a